Today we're going to talk about voice interaction systems.
So we'll begin by defining voice interaction systems. Voice interaction systems, or VIS, allow drivers to give voice-based commands to a car's infotainment system to prevent distracted driving. Many cars made after 2014 include some form of voice-based interaction. Commands may include placing a phone call, such as saying, "Call John Smith," opening and reciting a text, "Text Jane Doe, I am on my way," or changing the radio, such as saying, "Put on AM 800, along with navigation sequences.
VIS is believed to be a safer option in comparison to manually inputting information or using their phone. A number of studies has been conducted understanding the relationship between VIS, usability, safety, and cognitive workload of drivers. Many drivers use voice interaction systems commonly while driving, so understanding cognitive workload and distraction implications are important for safety and preventing accidents.
In 2018, Getty et al. Wanted to measure accuracy and delay in voice system and its effect on subjective workload of drivers. They had participants give voice commands to voice interaction systems in 8 2017 model cars from popular manufacturers. They found that subjective cognitive workload, including visual demand, auditory demand, and stress, all went up as system delay increased. Simply put, the less accurate a voice system is, the more auditory demand is present. And because attention is shared between the primary task of driving and the secondary task of giving a voice command, more distraction was present when compared to only driving in participants. The study also found that not all voice interaction systems are made equal, with different subjective workloads associated with each vehicle's onboard voice interactive system. Longer delay times and accuracy in task were both found to affect a driver's cognitive workload when carrying out tasks while executing a call demand. However, these two variables did not significantly affect mental demand or auditory demand when releasing a radio command, meaning that some tasks may induce more workload based on the nature of the task.
In 2019, Strayer et al. Tested Apple CarPlay and Android Auto against 5 other onboard vehicle interactive voice systems. This would also be known as the Original Equipment Manufacturers, or OEM. Participants in this study had to relay voice-based commands related to phone calling, text replying, music selection, and navigation entry. Findings in this study concluded that cognitive-based scores across native OEMs varied across different car manufacturers, while Apple CarPlay and Android Auto reported much less variability. Overall demands using Apple CarPlay and Android Auto did not differ. However, Apple CarPlay and Android Auto displayed different strengths and weaknesses. In other words, Apple CarPlay and Android Auto resulted in overall lower levels in workload compared to OEMs. Visual demands of both Apple CarPlay and Android Auto were notably lower. In all 3 systems, it was reported as being more demanding than the N-back reference test. In the N-back reference test, this is a numerical test where participants need to recall a previous number relayed in a sequence.
In 2013, Reimer et al. Evaluated subjective workload and basic driving skills while drivers interacted with a voice-controlled infotainment system compared to interacting with a manual system. They had 2 groups of participants in 2 age groups, aged 20 to 29 and 60 to 69. The visual demand from the voice interaction system resulted in glancing away from the road to look at the center console in some participants for up to over 30 seconds in a 2-minute simulation. Even though the National Highways Transportation Safety Administration recommends one should not look away for more than 12 seconds off the road in a minute, this task failed to reach their guideline. Some voice command tasks also took longer to complete, which resulted in a higher reported workload compared to manual input tasks. This included a song fail task, which was deliberately made to not correctly carry out the voice command. This demonstrates how accuracy of the system is important for reducing cognitive workload on the driver, similar to the study by Getty et al. Drivers also made some compensatory actions that could be dangerous while driving that reflect a higher demand on their cognitive system while interacting with their voice interaction systems. This includes slowing down while making a sequence of demands, such as inputting navigation information.
In 2016, Strayer investigated in-vehicle voice-operated infotainment system interactions and the cognitive workload of the driver. Participants in this study ranged from ages 21 to 70 years of age. The results of this study concluded that cognitive workload varied across all interactive voice systems in different vehicles. This emphasizes that not all voice interaction systems are uniform. Every car has its own onboard system with different levels of difficulty and intuitiveness on its operating abilities. It is also important to note that older participants reported more cognitive workload associated with voice interaction systems.
A difference reported between the three studies found that Getty et al. 2018 reported no significant change or increase in reported workload while participants were given a voice command task related to a radio function. This disputes findings by Reamer et al. 2013, who reports that participants reported more workload on the voice command radio task when compared to a 0-back and 1-back tests. A possible explanation for this is that older participants were included in Reamer et al.'s study when compared to the Getty 2018 study. It was reported in both Reamer's study and Strayer's 2016 study that older adults report more cognitive workload while working with a voice interactive system compared to the younger cohorts.
There were many key findings within these studies. To begin, voice-based systems are linked to a higher cognitive load on the driver when compared to a driving-only task. Certain onboard voice interaction systems are more difficult based on the manufacturing, influencing the user's experience and driver safety. The system's accuracy of command execution could have a significant effect on subjective workload of the driver. Finally, certain VIS like Apple CarPlay and Android Auto may reduce some of the cognitive and visual demands associated with infotainment systems. There is still a visual component to using the system.
After completing this literature review, a few gaps in the literature can still be identified for further investigation. The first being that these studies were conducted in a controlled environment to avoid harm to the participants, but real-life scenarios may have increased distraction or more stimulus to attend to compared to these simulations, such as pedestrians crossing the road or abrupt maneuvers to be done. The second unanswered question is that there's currently no dead-set rule on how much interaction can be involved in a voice interaction system during the manufacturing process of many on-board OEM systems. Although many of these studies concluded that voice interaction systems do still come with significant cognitive load and take attention off the primary task of driving, it would be interesting to see these data applied to parameters put on manufacturing companies for how to design a more intelligent, less demanding onboard system for the safety of the driver and everyone else on the road. The third and final question is that none of these studies mentioned using accents other than a North American accent in their study. Seeing if a system is better or worse at picking up certain accents would be interesting to study, and its effect on cognitive load, given that we know accuracy is an important factor in cognitive load, according to Reimer et al. And Getty et al.
These are our references.